Welcome back. In this lesson, we're going to continue looking at mountains and how mountains are formed. We'll see that there are various ways that mountains are formed, not just by plate tectonics, but by also other stresses that would lift up rocks and put them down. So we're on a grand scale because we're talking about whole ranges of mountains, but we'll look at some details. There are other types of mountains besides plate tectonic mountains. And one, I guess, is still plate tectonics, but it's not where it's being subducted. It's where it's being pulled away. So if you have two plates, such as the undersea plates, so I would like at the ridges, you've got one plate moving east and one moving west. What'll happen is that there is now a very thin region in between as they've pulled apart, and the magma that's under the crust is now being squeezed up to take its place. So new land is being continuously made there at the ocean ridges. Well, that's a mountain. That's very, very thin, and it's also buoyant because of the heat. So it's lifted up. So you do have a ridge there. That's a ridge is another way of we would call a mountain chain. So along the ocean floor, you've got an enormous, all the way down ridge crack in the bottom of the ocean floor that's also a hill. So this mountain is being pulled away. Now as it does pull away, it's not as high anymore, and it'll come down to a low area on both sides. But that initial middle of that ridge is a ridge, so that is a mountain, and that's one way mountains are made, as that new magma is coming up and cooling. As the crack is opening, as it widens, the molten material comes up and fills its place and then cools very quickly and becomes part of the ocean floor. So there is a bulge there, and so that's, I guess, considered a mountain. When you have a mountain, you often will have roots to that mountain as well because it is suspended in the mantle. So it's actually floating in a more dense material that's under the mountain called the mantle. So it's a semi-liquidy, fluidy, plasticky kind of more dense region. And the mountain, even though a mountain is very, very big and very massive, is floating in that mantle. We've looked at before that if that mountain were to erode, then it doesn't weigh as much. And if it's not weighing as much, it's not pushing down into the mantle as much. And if it's not pushing down enough to overcome the buoyancy of the mountain, or of the mantle will actually shove it up, and it will raise up higher than it used to be. So that's a little bit anti-intuitive, that you would imagine that it would erode away and it should get smaller, but actually what happens is that even though it gets smaller, it's lifted higher because it's less massive. There's not enough gravity pushing, or there's not enough mass of that mountain to push down the same as it was before because it's lost mass. Well, this is called uplift. When you have this isostatic rebound, it is called uplift. The mountain itself is now higher than it was. The rocks that used to be way, way underground could possibly be at surface level now. And so some of the mountains that you actually see, and some of the features of those mountains, like the serrated, jaggy, pointy parts of the mountains, could be older parts of the mountains that used to be lower down that has been lifted up. Okay, so this lesson is looking at the different types of mountains and what are the reasons these mountains are caused, what we see. Okay, so the first one, this uplift, so here's the example that I said before. This is called isostatic rebound. You've got erosion and transport, so that mountain is now less than it used to be, and the buoyancy of the underlying mantle is now higher than the weight of that mountain, and so it lifts it up. Okay, it would be as if you had a boat that wasn't so heavy and that it would ride higher in the water. So a loaded cargo ship is going to ride lower in the water because it's heavier. If you were to take some of the cars off of that cargo ship, and now that boat's not as heavy, it wouldn't go down into the water as much, it would be lifted up. So that thinking of that boat as the mountain, as it's eroded, it's lifted. And so now what used to be under the water is now at surface level. What used to be under the ground is now possibly at surface level. That's the idea. You have some other possibilities too. So there's another kind of a technical theory that if you had part of the lithosphere, which is part of the mantle, that upper part of the mantle, you had some denser regions sinking and some of the more melty regions taking its place, that it would give it more buoyancy. And it is possible that that more buoyancy would push up more and you could get an uplift. Okay, what could have been flat ground could now be a hill, and that is another possibility for these mountain ranges. So this idea of uplift, we're going to look at a few of these. So the first one that's very dramatic out west is plateaus. If you have an entire region that's now uplifted, so think of it as all it used to be ground level and now it's no longer ground level, it's raised up, then that whole thing is called a plateau. So a plateau is very flat. It's at the top of a hill. So it's a plateau at the top of the hill. So think of it a flat place at the top of a hill. Okay, so you actually have these in-mountain regions to where you would imagine that you would have hills and valleys, but you can have whole flat regions at the top of hills called plateaus. Now out west you have some really dramatic landscapes with canyons and mesas and all this tableland kind of stuff. You would have had a plateau originally and then eroded down to form these flat columny parts. So these mesas, mesa just means table in Spanish. So these geological structures that used to at one time be plateaus. Now a different type of mountains are formed from actual cracks in the rocks. So if you have pieces of the mountain where they're all in pieces and they're wedged together and there's pressure against each other, if that mountain is being forced or moving in any way, you can get different structures form. So certain parts can simply drop down, other parts can be pushed up. And so the fault block mountains, which are some of the really dramatic mountains, say in the Alps, are fault blocked where you've got pressures pushing them together. There's cracks in those rocks. Some are lifted higher, some are dropped down. The parts that are pushed up are called Horsts, and then Grabens, this is I think German, dropping down. And so you get kind of serrations in the mountains, up and down and up and down. Now eventually those will also erode and it'll look like just jiggy-jaggy kind of Dr. Seuss mountains. But what's actually happening is that you have large cracks in these mountains with pressures between them, like blocks in a wall.